Public keys are calculated from the private key using elliptic curve multiplication, and the main motivation or reason behind it is that it is irreversible or one-way, just like different hashes. The formula to get a public key is quite simple. We multiply our private key, which is small k, with a capital G generator, which is actually a point on the elliptic curve, and as a result, we will get our public key, which is another point on the elliptic curve with x and y coordinates. Now, the Bitcoin protocol uses a specific elliptic curve, which is also known as SEC P256K1, and it is defined by the following equation, which is y square mod p equal to x cube plus 7 mod p. Here, mod p indicates that we use a prime number actually, and we actually use a very big prime number, and the value is 2 raised to the power 256 minus 2 raised to the power 32, and so on. And main reason for using a prime number is that we get a scattered dots like pattern over the dimension. We will look at that visually also. Now we will discuss about elliptic curve arithmetic. So for scalars or normal numbers, just like your private key, we can actually add a scalar, subtract them, multiply, and even divide scalars. But for point arithmetic or specifically elliptic curve arithmetic, we can actually add 2 points and subtract them, but we can't multiply and divide 2 points. And but with scalar and point, we can actually multiply a scalar with a point and even divide a scalar with a point. And we actually do multiplication, scalar point multiplication for calculating the private key, which is we multiply our private key with the scalar point with the elliptic curve point generator. Now here is the visual, representation. Here is the normal, curve, elliptic curve over real numbers. But here is another example with, I think we are using here 17 as a prime number, and you can see that we are getting a scattered dots like pattern here. Now here's a visual, visualization of the multiplication with G. So here you can see that here we are just seeing different, you can say, different multiples of G here. And what really happens is that for a very small multiple of G, we can actually figure out after a lot of calculations that what's the, like for example 8G here, we can, after a lot of calculation, we might be able to figure out like it's like here at this point we are actually multiplying this with 8 here to get this point. But there are more, but for this specific point it could be 8G, 12G, 16G, or even like 1000G as well. So there's a lot of possibilities for a specific point on the curve. So for like our priority is a very big number, so it's like nearly impossible to define or figure out like this point here, this public G here, like what's the multiplier of this G here. So that's how we are, that's why we are creating the public keys basically.